Section 11.3 is radical equations. So we have been working on radical expressions and simplifying them. Once we get to radical equations, something with an equal sign, we're going to be solving. In other words, finding a value for x rather than just simplifying an expression into smallest terms. So let's take a look. Here's a very simple radical equation. Now, when you have 3 times x equals 9, this is a multiplication problem, and you use division to solve it. Right? So we divide both sides by 3, and we get x equals 3. When you have a square root equation, you're going to square both sides. So the square root of x squared is x. And 3 squared is 9, so my solution is 9. And I can check that back in the original. The square root of 9 is in fact 3. So that does check. Let's try another one. The square root of x plus 4 equals 5. If I square the square root, I'm back to where I started. If I square the 5, I have 25. Subtract 4 from both sides, and I get x equals 21. Again, to check this, I'm going to go back to my original, plug in my number, I get the square root of 25 equals 5, which is in fact true. So anything that's squared, no matter what's under here, if I square it, I'm back to the original number that I started with, before I took the square root. So what are our steps? The first thing we have to do is isolate the radical expression. In other words, the square root and whatever's under it has to be on one side of the equation, nothing else with it. Second, we're going to square both sides. That will remove the radical expression. And the last thing we do is solve for the variable. So let's look at one of these. So first, isolate the radical expression. This is my radical expression. I need to therefore get rid of the 7. So subtract 7. I now have the square root of x plus 1 equals 3. Now that the radical expression has been isolated, I square the radical. That removes it. X plus 1 equals 9. And the last thing I do is solve for the variable. So in this case, subtract 1, and x equals 8. Once again, my check is to plug it back in. So the square root of 9 plus 7 equals 10. 3 plus 7 equals 10. All right. So what happens if there's variables on both sides of the equation? So again, we have to isolate the variable expression, and it is all by itself. So the first step is to square both sides. The square eliminates the square root. On this side, this is a binomial squared. I have to either use my special pattern or FOIL. X times x is x squared. Multiply these two and double it up and square the last. Now I've got to isolate the x. Well, take a look at what we have. We've got a quadratic, x squared. So I'm going to move everything to one side. I'm going to subtract x and subtract 2. And now I have several options on how to solve this. I think factoring is going to work, so I'm going to use my factoring, x minus 7, x minus 2, and then set each of my factors equal to 0. So x equals 7, x equals 2. I could have done complete the square. I could have done the quadratic formula. And we have lots of tools now to solve a quadratic equation. All right, let's check these. I'm going to check x equals 7. The square root of 7 plus 2 equals 7 minus 4. The square root of 9 equals 3. 3 equals 3. Perfect. Now I'm going to check x equals 2. The square root of 2 plus 2 equals 2 minus 4. The square root of 4 equals negative 2, and that is not true. This is what is called an extraneous solution. Extraneous means extra and unnecessary. This is not a solution. It doesn't work in the original. Now, it is a solution of this line, but it is not a solution of the original. Look what happens when we square both sides of an equation. If I squared both sides of this, I would get 4 equals 4, and it seems to work. But when I'm just solving the original equation, when I don't square both sides, this negative sign on the right causes problems. So there is only one solution. It's x equals 7. So extraneous solutions sometimes occur when you square both sides of an equation, because if you square a negative, it acts like a positive. So always check your solutions in the original. Let's try one more. I want you to turn off the video, try this on your own, and see what happens. If you get stuck, turn it on and listen until the point where you got stuck, and then try to finish it off yourself. Okay, square both sides. So 2x squared minus 36 equals x squared. Move everything to one side so I can set this equal to 0 because it is a quadratic. Now, I can use several things to solve this. I can factor x minus 6 times x plus 6. I can use the quadratic formula, or I can simply move the 36 to the other side and take the square root. So x equals plus or minus 6. Let's check them both. X equals 6. The square root of 2 times 6 squared minus 36 equals 6. The square root of, that's going to be 72 minus 36, and that's going to be the square root of 36 equals 6. So that looks good. What about negative 6? Here's my problem. Again, when I put negative 6 inside the radical, everything looks pretty good because that's still the square root of 72 minus 36. But look what happens on the right. This negative sign does not match up when I get to the end, so that is extraneous. My only solution is x equals 6. So you can see how important it is to check all of your answers prior to putting them down on your paper. You want to make sure that they both work back in the original equation that you worked. All right.